We're going to grade an FRQ. This is the one that has to do with the father's and daughter's heights. And what you can see here is a scatter plot. So as soon as you can see that, there's probably sort of like a set of questions that sort of like pop up in your head. It's probably going to be an LSRL problem or some kind of what the fudge kind of question. Who knows? Now, the A part on this particular question, I would bet that most of you are going to get a 0 on part A. And it's very, very sad, but it's true. And it says, draw the least squares regression line on the scatter plot above. Now, if you just decided, oh, I think I'm going to put it here, and you try to come up with your own personal rendition of a best fit line, you're not going to receive any credit for it because it needs to be a good best fit line. They give you the equation right up here at the top. And the way that you learned in Algebra 1 is to start out with the y-intercept and then go up and over the slope, you know, rise over run. But you'll notice that the y-intercept is 35.1, which is right here within those little squigglies. There is no way you can sort of estimate where this line of best fit without doing a little bit of work, and this is what the AP was expecting. So what I would expect to see is, number one, there needs to be 2 points calculated, and the work needs to be shown. So that means choose 1 point and then another point, substituting each of them into the line of best fit to make a prediction. Come up with the coordinate, okay, and this is an x and then it'd be a y hat. You know, those are on the regression line. And then graph those 2 points and then use the side of your calculator or use the straightest line as you can that connects up those 2 points together. And that's going to give you the best line of fit. The AP is going to know where that line is supposed to be. So they're looking for actually something that's pretty exacting. So we had 1 point if you calculated 2 points using the regression line, all right? And then 1 point for actually graphing that regression line, and it needs to be in about this location, all right? There shouldn't be any, like it should not be slanted any differently, all right? So if I took patty paper and put it on top of your graph, the line would be in about the same place, okay? So part A is worth 2 points. My person got 2 out of the 2 because they showed work to find 2 points and they graphed the line. And guys, a lot of you, your line's probably going to be wrong because you just estimated and you really don't have a good line. And you also probably didn't show any work here to get 2 points that you know are on that line. So that is part A. The next part right here is one father's height is 67 inches and his daughter's height is 61 inches. This is the actual father-daughter pair. All right, so this is an X and a Y, and it says circle the point on the scatter plot that represents this pair. All right, your first check. Did you circle the right point? Okay, so this is the point. If you circled that point, give yourself a check mark. That's our first check for part B. Okay, and then it says draw the segment on the scatter plot that corresponds, that corresponds to the residual. Okay, that means the second check for part B is there needs to be a vertical segment that reaches up to that line of best fit. So if you have drawn a vertical segment, if it's slanted at all, it's wrong. So the second check is for that vertical segment. So far for part B, it's worth 2 points. All right. Now the next thing that I would want to see is I need to see substitution for that X value into the Y hat equation because we're supposed to calculate a numerical value for the residual. So eventually we're going to be figuring out what Y minus Y hat is, but before I can do that I have to have an equation. Now I want you to see what this person did. This is not what I would have done. I would have had some extraneous work. Y hat is equal to going back to the equation, 35.1 plus 0.427 times x, and you need to make sure you've shown substitution into x with that height that we're sort of checking out. So we're going to plug in 67, all right? So give yourself a check mark that you showed, okay, the first bit of work here by substituting 67 into the regression equation, and then your prediction for this particular value is 63.709. That's going to be check number 4. Okay, now this person that did it is going to receive credit because I see substitution right here, which is in the midst of the other formula. So they are showing the work required to get the prediction. They also get credit for showing the resulting value for y hat because they have it right here. So my person does get both of these checks too. Okay? So the next check is going to be, do you have the formula for the residual? Y minus y hat. Do you have substitution into the residual? Check mark for that. And then, do you have an answer for the residual, which is negative 2.709? You get a check mark for that. And then, do you have proper units? It's whatever the y units are. Do you have, that is going to be your last check. So for this particular problem, there are, all right, a bunch of different checks right here. Okay? There is a check mark for circling, a check mark for the vertical line representing the residual. That's 2. And that means 3, 4, 5, 6, 7, 8. There are 8 checks right here. My person got 8 out of 8. They didn't do it exactly how that I would have done it. But if you look at their work, they do get all the points that I'm looking for. So this one is worth 8 points. Now the last part, C right here, is suppose the point 8471 is added to the data set. And they're asking, would the slope of the least squares regression line increase, decrease, or remain the same? Explain. And then would the correlation increase, decrease, or remain the same? Explain. So the first thing that we're going to need to do is make sure you know where that point is. All right, it's 8471. And it ends up being this little dot right here that this particular student actually put a star there, which I've just now covered up. That is the point. Okay? So by adding in that point, the slope stays the same. So a check mark for saying that the slope stays the same, but then you have to explain why it stays the same. And that means you need to make sure that you have gotten across the point that that dot lies along the LSRL. It follows the pattern. It has the same trend. It follows the same path as our regression line. Something like that is going to justify, okay? It almost falls on the existing line. Check. Okay? Since it's really close to the regression line that we've already calculated, we know it's not going to be influential, and the slope is going to be the same. So if you've talked about that, that's going to give you justification credit. So that little part, okay, is worth 2 out of 2. Now for the correlation, by adding this point in, we also have to figure out what happens to the correlation coefficient. To make that decision, you have to decide, does that point add to its linearity? Does that make it look more linear or less linear or about the same linear? Adding this point in actually makes it look more linear. So the correlation coefficient is going to increase. So the next step is making sure you've said that, the correlation will increase. All right? And now you need to justify that particular answer. And so what I'm looking for is something like that the linear pattern is stronger, that it makes the line look more linear looking. It sort of extends the line, making it a much better linear pattern. Okay? So that's what you need to get across. So read through your work and make sure that oh, look at that. It strengthens the linear pattern and gets the line closer to 1. It's near the high end of the domain. It increases the scope of the least squares regression line. There's enough there for me to give credit for that. So this one is worth 2 points also. My person gets 2 out of 2. But you need to get across the point that it increases the correlation coefficient because the pattern of linearity is stronger. Remember, correlation is a measure of linearity. So that means if it's more linear, R is going to get bigger. Okay? So in this particular problem, let's add up the total number of points. 2 plus 2 is 4. 4 plus 8 is 12. 12 plus 2 is equal to 14. The total number of points possible is 14 points. My person got all 14 out of 14. Now, my person actually didn't. I don't know if you noticed that was in my handwriting. They wouldn't have not gotten points there. All right? Put your score out of 14 at the top. And then make sure that eventually when you got all of your FRQs graded, you'll be able to submit to the hub. Thanks.